Need a histogram in Pari? Pari doesn't have one. That's disappointing. I needed one, but with a twist. I needed to count data whose type was not an integer or real. This is an episode on how to do it. But first, we start with the ideas in episode 1 for integers. Here's the MATLAB code, and above it the equivalent Pari code. In MATLAB, we start with a sort of the data. Pari, it's the same. The next step is a little more interesting. In MATLAB, we find where the sorted list of data changes and get those indices. In Pari, we need to do the same. That means we need a vective function, which doesn't exist in Pari. This is custom. Then we need a replacement for the find to give us the indices where those values change. This is IDX-GTR. The rest of these functions are pretty much the same. The test program, T and hist, can be very similar to the one in MATLAB. Here, vec_rand_i is an imitation of rand_i in MATLAB, which generates integers in a certain range. Then the histogram is run 10,000 times with data length 100 and 100 bins. Notice that we have inserted our custom support functions needed at the top for emphasis. Once you have built a personal collection of support functions, they can form a library of sorts, and Pari can read them at startup by putting them into .gprc.gp. Let's run it. Here we see the time in Pari is 3 times faster than Octave at this task, but over 4 times slower than MATLAB. Suppose, however, I didn't just have integers. In fact, I actually wanted to count finite field elements. How? In order to do a fast histogram, a sort is critical. But how to sort objects that have no natural order? We could impose an order, but as it turns out, we do not have to. Pari has already done that, and that is the one-liner we need. Here it is. Vec_sort is a normal Pari function. What's unique about it is you use the generic comparison operator. This operator uses the internal representation to order elements in almost any data type. Here is a test of 4 different data types: finite field, modulo integers, binary polynomials, and binary rational functions. This test code has 7 custom support functions. At the very top, pos, false, bin equal, bin rand 0, vec idif, idx 0. See the GitHub gist for their description. Let's run it. Here we see the count first, and then the bin types second. This ends with, for example, a count of 2, 1, 2, etc. to 1 of binary rational functions, and this is the list of them. That's all for now.